Okay, we're picking back up, guys, where we left off. So, we're gonna look at some of the more challenging, not necessarily challenging, but just like more in-depth implicit differentiation problems and applications of it that you'll see. So, if we kept on going to classwork, you'd see here what are the slopes of the tangent line at x equals 0 and x equals 1. Confirm the slopes look correct in the graph. So, what this is saying is, okay, well, what's the actual slope here? What are the slopes at when x is 0, x is 1, or when x is 1, right? So that's what it's saying. It's like actually like, what is the slope there actually? And to do that, you need coordinates. So if we think about when x is 0, there's actually 2 points when x is 0. So for example, we have 0, -1 right here, and we also have 0, comma 1. So going to the notes for just a moment here. I'm on page 6 of the notes. This is like the other question type that you'll get, which is to find the derivative at a point. So a very common one is that you're given that point. So in this case, see how I just got those points, 0, -1, and 0, 1. All you do is just take the derivative implicitly, like we did before, and then we plug in that coordinate. That's all it is. Okay. So if we go back to our original example, um, we ended up with this. This was our derivative. So if I want the derivative uh, at like 0, 1, my x will equal 0 and my y will equal 1, and I'm just going to plug them into that. Okay, you follow me? So it's going to be -2, 0, plus 1 over -0 plus 2 times 1. And when we simplify that, sorry, let me move that up a little bit. I just subbed in everything for x, 0, for y, 1. One thing I really recommend you get the habit in is like whenever you're like doing this inputting thing, like inputting something for x, just put parentheses around whatever you're inputting. Pretend like this x, whatever that was, is now parentheses 0, right? And so when that cancels to 0, this is just 1 over 2. So that's your slope. At 0, 1, what that's saying is, if we go back to here, right here, my slope is 1/2. That's what that's saying, right? That's saying that the slope, the m, is 1/2. Okay. All right. So again, same for 0, -1. You just plug in 0, comma -1, and you get that slope. Okay. Um, I'm gonna do some more of those problems. So if you feel you got that, you're good to go. If you want me to, I'm gonna go through these two in the notes. Just to make sure you're good, including kind of a more tricky one. So I'm going to go through 2 different problems right here. Let's do it. So this is a delta kind of problem, straight from delta. Very AP test S. Okay, so we want the derivative at the point -4, 2. We're going to have to differentiate this implicitly. I'm going to stick to that purple dy dx, but otherwise I might not be quite as detailed as normal. We're going to have 4y dy dx, because it's a y, plus 6y squared dy dx equals 4 dy dx plus 2x. Okay, I am going to move this 4 dy dx over because I want it over to be with its friends. So I'm going to do -4 dy dx from both sides. Okay, and then I'll rewrite it. We're going to have 4y dy dx plus 6y squared dy dx, now minus the 4y. Just the 4 dy dx. You can see how when you're doing these problems, it's so easy to make mistakes, huh? Equals just 2x. Okay, then we'll go ahead and factor that dy dx out. So we get dy dx out front, and then parentheses, we got 4y plus 6y squared minus 4 equals 2x. From here, I'm out of space, but I'm dividing both sides by 4y plus 6y squared minus 4. I'll go crazy and show that work, huh? Let's go crazy here. So I'm going to divide this, right, by 4y plus 6y squared minus 4, and also this one by 4y plus 6y squared minus 4. And again, what ends up happening there is that these will cancel, right? That will cancel with that, and we will be left with over here dy dx equals 2x over 4y plus 6y squared minus 4. From here, so we implicitly differentiated. You should be kind of getting a little bit more familiar with that by this point. Now we're gonna just take these coordinates and plug them in. So remember, x equals 4, y equals 2, and just very, very carefully, you're gonna input those in. So we're gonna do 2 times 4. Remember, parentheses. Wherever there's the value, I'm putting parentheses around it just to make it super clear. 4 parentheses 2 plus 6 parentheses 2 squared minus 4. Don't get lazy with the order operations, guys. 2 times 4 is 8. 4 times 2 is 8. 2 squared is 4. 4 times 6, 24. Minus 4. That's what I'm seeing the most, just order of operation stuff. And so that goes down here to 8 over, that's 20 plus 8, 28. That'll simplify a little bit to be 4 over 7. I divide, oh my god, sorry, not 4 over 7, yes, no, sorry. Okay, let me pause for a second. Divide top and bottom, let me write it again, 8 over 28. I'm dividing top and bottom by 4, divide by 4. That is 2 over 7. That is the final answer. Let's not rush it. Take your time. Take your time. Okay? So that first answer here, right here, would be 2 over 7. Okay? That's the answer. So take the derivative, implicitly differentiate, plug in x, 4 for x, y, 2 for y. Boom. You got your answer. All right. If xy equals y squared minus 2, then find the equations of all tangent lines to the curve when x equals 1. Okay, this is a little spicier, this one. Okay, so this is kind of following this method here. If you're only given an x value, in this case I'm only given an x value, you're going to take that x value and you're going to plug it into the equation and get y. Then when you have that, you're going to have your coordinates, and then we kind of follow this step all over again. Okay, and then from there you will then get your equations of your tangent lines. Okay, let me show you. So step 1, we're going to plug it in. We're going to get negative 1y, right? I'm just putting a 1 in there. Remember, parentheses around it, equals y squared minus 2. I have a quadratic, so I'm going to have what looks like two solutions here. I'm going to move everything over to the right side. So I'm going to add y to both sides here. I'm going to plus y. We're going to plus y. And I will have, when I reorganize things, I'll have 0 equals y squared plus y minus 2. Okay, makes sense? What did I do so far? I plugged in a 1 for x because that's all I had. That's just negative y. I added y, I got this. Follow me? Then we got our factors. So here my factors are going to be, remember this equals 0. Y, you factor this just like you would factor anything. Two numbers multiply, get negative 2, add to get 1. We've got plus 2 and y minus 1, which means that my solutions are y equals negative 2 and y equals 1. All right, so now I've got my coordinates. I've got two sets of coordinates now. I've got a set of coordinates at 1 comma negative 2, right? Because my x is 1 comma negative 2, and I've got another at 1 comma 1. Okay? Following me so far? So that's step 1 done. You plug in the x value in, you get your y. Sometimes there'll just be one y value, and sometimes if it's a quadratic, there could be 2. So you get here, and then you've got your coordinates. Okay? All right, continuing. What's next? We need the derivative. We need to implicitly differentiate this. So let's do it. Negative xy equals y squared minus 2. Let's implicitly differentiate. We got a little mini product rule over here on the left. We're going to take that negative out because I like to keep it separate, and then I like to distribute it. I think it saves me making mistakes. So again, this negative, I'm just keeping it out. I'm not engaging with it, right? I'm just doing a lefty right on this. Left x, d right, dy dx. Left d right plus right d left is just plus y. We're done. Equals 2y dy dx. Okay. And then negative 2 is 0. Right? Okay. So here we go. Let's distribute this a little bit, make it a little cleaner. Negative x dy dx minus y equals 2y dy dx. That was just me distributing that negative to both of those. From here, we need to, oh, I stopped my little streak of using purple. Let me put purple back on this to make sure that's clear. All right, there we go. We're just going to make sure these are on the same side, so I can just add that x dy dx over. We're going to plus x dy dx, and plus over here we're going to do plus x dy dx. So now I will have negative y equals 2y dy dx plus x dy dx. Okay, good. Now we just do the little factor. So we're going to take the factor out, dy dx, 2y plus x equals negative y. And then we will divide both sides by 2y plus x, 2y plus x. This is an x. And of course that cancels here. Doop, doop. So my derivative dy dx equals negative y over 2y plus x. Okay, so now remember my 2 points were 1, negative 2 and 1, 1. Okay, so I've got 1, negative 2 and 1, 1. And remember, we're trying to get the equations to these lines, not just the slopes. We need the equations. Okay, so let's do one at a time. I'm gonna put it down here. So 1, negative 2. Let's take out 1, negative 2. X would equal 1, y would equal negative 2. Let's plug it in. So we're gonna get negative 2, right? Let's be putting that in. 2, negative 2 plus 1. That's gonna be 2 over, that's negative 4 plus 1. That is 2 over negative 3. So my slope for 1 comma negative 2 is 2 over negative 3. Okay. Continuing down. For my other coordinate 1, 1, same thing. I have negative 1 over, or just parentheses around that, over 2, 1 plus 1. It's going to be negative 1 over 2 plus 1 is just 3. So that is my m for 1, 1. So what we have is we have two points, and we have everything we need now. We have our line. We have our first point at 1 comma negative 2. Okay, for 1 comma negative 2, my x is 1, my y is negative 2, and my m is negative 2/3, right? So when we write our equation, it's going to be y plus 2 equals mx minus 1. And then for 1, 1, it's going to be, so and x equals 1, y equals 1, and m equals negative 1/3. Oh my goodness, guys. Sorry, for this one, y plus 2 equals, my m was negative 2/3 x minus 1. Okay? And then for this one, x equals 1, y equals 1, m equals negative 1/3. It's going to be y minus 1 equals negative 1/3 x minus 1. So again, the formula that I'm using here, I didn't specify this, but the formula that I'm using is y minus y1 equals mx minus x1. So my answers, final answers, would be this one and this one. Okay, that is a challenging problem for sure, no doubt about it, guys. That is a tough problem. Let me recap the steps one more time from the beginning. First, you need your coordinates. So you take the 1, you plug that in to here, right? You plug in a 1. We got a quadratic, y squared plus y minus 2. We solved that, set it to 0, we factored it, we got our 2 points, negative 2 and 1. That got us our 2 points, 1 comma negative 2 and 1 comma 1. That's our x value is 1, that's why it's 1 here and here, and then our y value was negative 2 and 1. Okay? Then we implicitly differentiated. So you took the derivative implicitly, that's the work for that. Got it all the way down to the bottom, found what the derivative was. Then we plugged in our coordinates, 1, negative 2, in. We got the slope for it. Then we plugged in 1 and 1. Got the slope for it. And then using our x, y, and m, our point and our slope, we wrote the equation for 2 different tangent lines. Okay, that is B. All right, we're on the home straight here. Okay. Other questions. Finding points given a slope. So that was finding the slope at a point. Now, or the equation at a point. Now you sometimes be asked to find the point given the slope. So sometimes you're told, okay, well, where do we have a horizontal slope, or where do we have a vertical slope, or where do we have any numerical slope? So a horizontal slope would be when the numerator of the derivative is 0. Okay. A note here is that the denominator cannot equal 0. Same thing here. The vertical slope is when the denominator is equal to 0. The numerator, right, cannot equal 0 as well, right? And if it's just a numerical slope, you just set the derivative equal to the slope. So the steps are: we set the derivative equal to the slope. You plug in the x value into the derivative. This should be, just make sure that equation, this is derivative. That should be more specific. Then you get your coordinate. Then you plug that combination into the original equation. And if it works, there is a point. If it doesn't work, it's no point. So let me show you an example of that. Okay, if x cubed y minus 4x cubed plus y equals 4, and is known that the derivative is this. Nicely, thank goodness, we do not need to implicitly differentiate. The derivative is here for us. Okay? We need to find all coordinate points where x is 1 and the tangent line of the curve is horizontal, or state that no position points exist. So horizontal, you're going to follow this as a guide. If it's a horizontal, you got to set the numerator equal to 0. So here we go. We're going to say negative 3x squared y plus 12x squared. We're going to set that equal to 0. And we know that x equals 1. So that means everywhere there's an x, I'm just going to replace that with a 1. So we're going to have negative 3, 1 squared y plus 12, 1 squared equals 0. This is going to simplify to just be negative 3y plus 12 equals 0. We're going to simplify this a little bit more. So again, minus 12, minus 12. We're going to give negative 3y equals negative 12. Divide by negative 3, divide by negative 3. Y equals 4. So my coordinate is x equals 1, y equals 4. My coordinate is 1, 4. Follow me? Also, this is a point where you would like just make sure that you're not getting any 0 in the denominator, and I can see I'm not, okay, there is no y in the denominator anyway, and when I plug in a 1, I get a 2. So I'm good. This is a good point. Now I'll take the 1, 4, and I'm going to plug it in to my original, all right? So this goes into original. Okay, so let's do that. Here we go. It's going to be 1 cubed 4 minus 4 1 cubed plus 4 equals 4. 1 times 4 is 4, minus 4 plus 4 equals 4. So these will cancel, right? That's just 0. Sorry, Jesus Louise, that's a 4. 4 equals 4. It's good. So we can say, because it works in the equation, that 1 comma 4 is our solution. That is the point where we have a horizontal tangent line, meaning that if our function, I have no idea what this looks like, but if our function looks something like this, then we would have at 1, 4 this horizontal tangent. Okay? All right, that should get you going with a few more problems.